Hi, I'm Liz Bradley from the University of Colorado, and I'm going to be speaking here on behalf of the Computing Community Consortium. Now, virtual presentations are not optimal, and pre-recorded presentations are even worse. So what I'm going to do in order to try to address this for people who may be skimming lots of presentations is to try to give you the gist of this talk in 2 minutes or less and point you to the takeaways, which are on the last slide of this deck, which you can download from the conference website. So probably everybody who is viewing this talk is aware of climate models, the chunks of computer code that predict what climate change will do to the oceans, the ice pack, the temperature, the weather, and so on and so forth. But that is only a very small part of what computing can do to help us respond to the climate emergency. Computing can also, and is also, unfortunately contributing to climate change, and I'll say a bit more about that. A couple of other important points that I want to make. People in the computing field need to know what the problems are so that they can figure out whether or not they can help create solutions to those problems. And people in other fields, in order to help with this effort, need to know a little bit about what computing research can bring to the table. For all this to happen, there need to be communication channels that connect these two communities. Currently, that's lacking, and we're trying to fix that. And I'll say a little bit more about who we is later on. Communication across discipline boundaries is famously hard, and even inside the computing field, there are silos that are going to pose challenges to this effort of getting all hands on deck to respond to the emergency. And in order to fix this, we need your help. So what I'm going to do for the next 5 minutes or so is give you a few examples of how computing can help. Of course, again, there are climate models, the top left, but computer algorithms can also be used to optimize, for example, the design of sensor networks for monitoring different salient variables. And the computer algorithms can also take the flood of data that's coming off of sensors like that and distilling it down into useful information. Applications here range from wildfire to drought to precision agriculture. There are a ton of other important and interesting applications of computing research in agriculture. For example, if you have the conditions in a field, you know what the soil is, what the fertilizer is, where the water is, where the shade is, and so on and so forth, a computer model could be built to figure out, given a particular crop, how well it would do in that field. And that could be used by a farmer to optimize the placement of the crops. And not just now, but in the future, because all you have to do is figure out what that field is going to look like as the climate changes. And that would be much better than doing what I do in my garden, which is plant something someplace and see if it lives. Much better to do a priori with a computer algorithm and not waste your time in your crops. Similar computer algorithms can enable what-if analysis of networked systems like the power grids and supply chain networks that undergird the world economy, and study how those systems will react to the kinds of extreme events that are going to become much more common in a warming world. The same pieces of computer code, the same models, can be used to plan responses. For example, to plan rolling blackouts that minimize harm while protecting the power grid. That word harm brings up another important matter, environmental justice. Climate change is, we know this, going to differentially impact disadvantaged people. Some people have the resources to adapt or to protect themselves, for example, to build their houses to survive the hurricanes, or just to move to an area that's not going to be flooded. These kinds of issues and effects have traditionally not been captured very accurately in formal assessments of harms or formal models of this, but it's actually not hard to plug that kind of information into a computer model, as long as those of us who are building the models have people like you to advise us about what the harms are and what their effects are. Now, that's actually once the knowledge exists, plugging it in is not hard, but gathering that knowledge is actually quite difficult because computers are rigid. They require extremely precise descriptions of things, specific variables for the things that matter, related by actual equations that specify how each of those variables factors into the harms and what their costs are. Here's an interesting example of how hard that can be. The obvious calculation, if you are figuring out where to put charging stations for electric vehicles, is to put more of them where there are more people. But it turns out that shortchanges rural communities. Kind of obvious in retrospect, but it is the first obvious thing to do, is to try and do it that way. The issue here is that figuring out what to put in the models, how to do the calculations, gets quite hard when you have what's called a socio-technical problem. It's not just the technology, it's also the people. And solving these kinds of problems requires deep collaborations between the model builders and the people who know about the systems being modeled. And importantly, these kinds of collaborations need to be ongoing and iterative. So when you plug something in and it doesn't work, you say, oh, let's try this instead. What if analyses enabled by computing research can help people understand how climate change is going to hit home for them? This image, unlike the rest of my talk, is not under Creative Commons license, but I really wanted to show you the web page, and it's hard to do that on a Zoom recording. So hopefully the New York Times will not get too upset. The link is at the bottom of my slide. What this app does, or what this web page does, is allow you to select a city and allow you to move a slider for how much sea level is going to rise. And then you can see which part of your city, your chosen city, is going to be underwater. This kind of thing is not just important for people to understand, it can be particularly compelling for policymakers and decision makers, the people that we really need to get to understand all of this, because it helps them see how climate change, sea level rise, whatever, will impact the people who vote for them. Now, connecting back to the previous slide, what if we wanted to overlay socioeconomic indicators on top of this map to see how the combined effects work? That's just a few more lines in the code, really. But we computing people need you subject matter experts to tell us what to have our code do. So computing can be part of the solution, but it also is part of the problem. Training these large language models that we've all been hearing about, and some of us have played with, requires or generates tons of CO2, scores of tons of CO2 equivalent. This, by the way, is training them, not using them. For context, my not flying to France for this conference saved the world about 2 tons of CO2 equivalent. Bitcoin mining is a horrible culprit, not tons, but megatons of CO2 equivalent, which is larger than the emissions of most nations. And speaking of flying, the cloud storage and cloud computing that so many of us use, like Dropbox, Google Drive, Amazon Web Services, that infrastructure is now to the point of generating more CO2 equivalent than the entire airline industry. So there are tons of important problems to tackle here, but there is no central, at least currently, no single central nexus, point of contact, clearinghouse, place to go if you want to learn about or contribute to research at the intersection of computing and climate change. Computing researchers who are thinking about problems at that intersection or who have skills that could contribute are spread around among disjoint intellectual subcommunities in the computing field. There's the machine learning, there's the programming languages, there's the numerical people. And they don't have connections, very few of them have connections to people on the climate side. And a lot of them don't even know that their work could help with the climate crisis. There are some beginnings of efforts to fix this, notably in the machine learning subfield of computing research, which is machine learning, data science, statistics. So there's some clearinghouses, some research networks for that. There's some other efforts that are broader across, for example, all of science and engineering, or focused on energy across all of science and engineering. But we need to reach much more broadly. And again, that's hard because people are ensconced in their silos. The optimization people don't go to the machine learning conferences and vice versa. By the way, there may be other efforts besides the ones screenshotted on this slide. If you know of any, please let us know. I have a link to a contact form on my last slide. So we're trying to fix this. Who's we? We is the Computing Community Consortium, which operates under the umbrella of the Computing Research Association. Lots of buzzwords. The Computing Research Association, or CRA, is a nonprofit in DC whose members are university computing departments and industry labs all across North America. So my department is a member, Microsoft Research is a member. You can think about the CCC, which is the piece of the CRA that thinks about research, as a bridge between the computing research community, the funders of that research, and the beneficiaries of that research. We are fundamentally a purpose-driven organization, just like the focus of your conference this year. Our specific purpose is to figure out where computing research is and where it should be in 5, 10, 20 years, and hopefully to figure out how to get it there, how to help get it there at least. Climate change is obviously one of the most pressing global challenges of our time, and the CCC has chosen it as one of our foci. We are hoping in doing so to leverage the parent organizations, the CRA's organizations, position as the umbrella organization for all of computing research across all of North America. We're hoping to leverage, that's a powerful thing, and we're hoping to leverage that and the associated connections and visibility to make some progress on this project. We have staff also, we have funding to support this effort. And the parent organization, the CRA, has a government affairs office with people who know how to take the outputs of an effort like this to the policymakers. How does CCC work? We pick a focus area and we start probably generally with a white paper. We pull together people from across the computing research community, a range of different fields and institutions, as you can see here, together with some subject matter experts. We think about, brainstorm about the state of the research and where it needs to be in order to address the focus area, move things forward, move the needle. And then we write a 2 or 3 or 4 or 5 page paper, a white paper. And these go out to the computing research community, but also through that government affairs office that I mentioned, to policymakers and decision makers. The US National Science Foundation, the US Congress through its congressional committees, like the House Committee on Science and Technology. We have connections to get these papers to the White House through its Office of Science and Technology Policy, which is the science advisor to the White House. And our papers also go to other professional organizations like the Association for Computing, ACM, and the IEEE. Our goal for this particular white paper was to educate the computing folks about this impact area and help them start to see how their skills could help. And the second goal was to educate, to start at least, to educate the policymakers and decision makers about how computing can help and hurt in the context of the climate emergency. The ultimate goal, of course, is similar to the goals that I'm speaking to you about, is to help move forward policy, to create funding streams, and so on and so forth, to support the research to address this issue. Raising awareness is one important thrust of our efforts. Another is building connections between researchers. To that end, we're creating a climate network. Here, the goals are first to find out who is working at that intersection between computing and climate change. And secondly, to bring more people and more energy into that intersection. For example, the optimization person who hadn't thought about how her techniques could be used to figure out the most equitable, efficient, and climate resilient distribution of electric vehicle charging stations. We're doing this with LinkedIn. Here's what the page looks like. I have a QR code on my last slide that I would love for you to scan. By the way, we chose a network rather than just a list in order to capture not only the people who are doing this stuff, but who's already collaborating and who could be collaborating. The third step in our to-do list goes directly back to that point about there being no central nexus at this point for this kind of work. Ideally, there would be a broadly known interdisciplinary international computing and climate conference every year with an associated journal, very much like this conference and the Common Ground Journal that your community started in 2009, except specifically focused on this intersection right there. Again, this kind of thing is starting in some sub-areas of computing, notably this machine learning subfield. But we need to get this entire area. We need to get everybody, again, all hands on deck. And of course, what we really need is for the big funding agencies around the world to start putting resources into this intersection. And if we build out these connections, support the research, the resulting research, and educate the policymakers and the public about the results, maybe we can even help move policy forwards. But obviously, that's a pretty tough problem. So what you can do, you can join our climate network. You can help us route people, ideas, and energy into this important intersectional research area. Our network can, for example, help connect you to computing researchers who are interested in solving your problems. We are just starting this up, so we welcome feedback about what would be useful in such an operation. We are planning to populate it with carefully curated information about research at this intersection. For example, exposure spotlights on students, researchers, projects, conferences, etc. We are curating it so it will hopefully not have a lot of junk on it. It will be high, as we put it in engineering, signal to noise ratio. And I should end by saying, of course, there are problems that computing will not be able to help with, but we need to have these conversations in order to find the ones where we can help. And while we're a North American organization, and that's where we're starting this effort, we need your help globalizing this. So thank you for listening. And please, if there's something that we should know about, there's a contact form and there's a QR code to find out more about our LinkedIn network.